one can be applied to understand linear algebra in a better way. I have taken this example from GitHub. There is a scattered data as shown in this figure, and I need to fit a straight line. I need to model it as a straight line using least square technique. For that, I need to import certain libraries. I have imported 3 libraries. Import pandas as CD, import numpy as NP, import matplotlib as PLT. This particular library is used for drawing the figures. First, we need to pre-process the input data. Data is stored in the form of Excel data.csv, and so I am reading it. So that is stored in the data. Now it has 2 columns of data. One column will contain x values, other column will contain y values. So x is the data.ida first column, and this is the second column. After that, we are plotting the data that has come here, where you can see that the scattered data we have. Later on, we need to build the model. To build the model, we need to find the mean of the value. That we have done it using np.mean of x. Similarly, we need to find the mean value of y, np.mean of y. It is the straight line fit we are going to have. Straight line equation is always given by y is equal to mx plus c. So we need to compute the slope and the intercept values m and c. And for that, actually we need to we have calculated the mean value. So we have different values of x and we have different values of y. Corresponding to these x and y, we have added all these values and we have calculated x mean. Similarly, here we have calculated y mean. Now we should have one more column where we have this minus x mean, and the other one is y minus y mean, and we have to multiply these two to get the numerator. So if I call this as A, this as B, and C, D, then it is C into D, you'll get the numerator. Denominator value will be equal to the C value whole square, or C into C. So this is what has been done using the for loop. You can see this is the for loop we have used here to compute the value of m. So x mean is calculated, y mean is calculated. So we can always get the difference of the value minus the x mean. Similarly, the difference of y minus the y mean. In the denominator, you have xi minus x mean whole square. Dividing the numerator by the denominator, we can get the value of m. So once we know the value of m, you can always find c. C is given by is the y mean minus m into x mean. If you want to see these two values, or you can always write the print statement and observe the values of m and c. Once we know the value or values of m and c, we can always make the prediction. So y prediction is given by m into x plus c, and this has been plotted here using red color. So this is a straight line which is a square line fit to the scattered data. In the second example, let us try to get 3 matrices using singular value decomposition method, that is U, sigma, V transpose matrix. For that, we need to import libraries. From numpy, we have imported array. From scipy, we have imported std. In the earlier video, I have solved this problem. So here we have to define the matrix A, and that is the array of 4, 0, 3, minus 5. And if I want to observe the matrix, I need to make use of print statement, and when I execute this code, I am going to get the output as A is equal to 403 minus 5. Then I have to apply the HCD. In order to get the three matrices, U sigma V transpose is equal to HCD of A. So U will be U matrix, sigma will be sigma matrix, and VT will be V transpose matrix. All these three matrices will be printed because I use the print statement. So in the output, I will be getting U matrices, sigma matrices, and V transpose matrices. You can verify the answers. In this particular example, I want to reconstruct the given matrix A after decomposition. So I need to import certain libraries. I have imported array from NumPy, DIKG from NumPy, then dot from NumPy, and SVD from SciPy. First, let us define the matrix. A is the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. So since I have given a print statement, when I execute this program, output I will be getting a display of A matrix. Later on, we need to decompose this matrix into U, sigma, and V transpose. Here I have used it as S. So U S V transpose is VTU of A. Once I get the eigenvalues, these eigenvalues are to be put in the form of a matrix, which is a n cross n matrix. So that's why I have used this sigma is equal to diagonalization of S values. Once I know these sigma matrix, U matrix, and V transpose matrix, I can always reconstruct it as U dot sigma dot V transpose. So this V matrix, whatever I get here, should be same as that of A matrix. That can be seen from the output. When I execute this code, I get V is equal to this. It's the same as that of this. So successfully we could reconstruct the matrix. With this, we complete module number 4 and 5, that is on linear algebra. In the next video, we move on to module number 1, which is on random variable, that is on probability.